So when you're dealing with a shifting version of sine and cosine, that's all we're going to worry about today is sine and cosine stuff. Tomorrow we'll talk about tangents, and we'll do tangents and their shifts tomorrow. When you're worried about sine and cosine shifted graphs, you're just doing the same basic principle. You're going to label your A, your B, your H, and your K. Your H and your K are your horizontal and your vertical shifts. So you still do the same thing. A equals, B equals, H equals, and K equals. You do that for either one of them. A is still your amplitude. Your period for both of these is still 2 pi over B. Remember, amplitude wise is still absolute value. So it tells you what direction. Remember, the A value tells you direction of whether you're going up first or you're going down first, whatever, something like that. The biggest trick here that you will see from time to time is that I want you to notice that the B value is outside of the parentheses of the X. You see that? Mm-hmm. A lot of times what they might do to you is they might sneak a B value in. For example, they might do something like this. 4 cosine of 3x plus 9 minus 6. They might sneak something in like that on you. So you'd have to take out the 3. Okay. That's usually the biggest concern that you'll see in this case. I probably should have put a pi in that just so you guys don't freak out too much. But that's kind of what it would look like. That's the biggest quick catch-all that they will do to you. To be honest with you, it's really easy to use this method, or sorry, the H and K method in sine and cosine graphs. When I show you guys how to work with the reciprocal property ones, I'm going to show you a different way to do it. It's actually, for the reciprocal ones, it makes a lot more sense because there's a lot less work involved. But for the sine and cosine, it's more of a structure. Do it this way every time. You'll be very hard pressed to get it wrong. It should make you happy.
Yeah.
So let me show you an example. Negative 2 plus 3 sine 4 times the quantity x minus pi over 2. Might as well jump right in with an h and a k. You don't need to just do k values because that's too easy.
Is that parenthesis just around the x ones?
Yes. So what do you think I'm going to do first? Yes, ma'am. A lot of times for the negative values, the k value will float to the front and the back. It just depends on, I don't know, what side of the bed they woke up that morning when they wrote out the problem. Whether the left or the right. Yes, ma'am. Sine and cosine are always periods 2 pi over b. Absolutely. Yeah. So start out, your A value is 3, your B value is 4, H value is pi over 2, good. And K is 2. So with an H and a K of pi over 2 for H and a K value of negative 2, what direction is this going? Yes, sir? Remember, if it's x minus h, it's the opposite sign. If it's plus k, it is the sign. Okay,
It's going
To the right.
down to the right.
it's going to the right and down. Yep. So, assuming. It's always helpful to throw a couple of arrows. That way you don't make a doofus move, and not forget which way is left or right. So, what's your parent graph?
Sine
3 sine 4x. So you're going to graph your parent. Oh, forgot to label my amplitude real quick. My amplitude, 3, period is 2 pi over 4, otherwise known as pi over 2. Okay. So when you graph these, you want to graph your parent function first. Yes, ma'am?
I'm just kind of dumb. That's not the only two things I
No. Dumb one. I can at least make it look like it's simple before you get hit in the head, right? Not like you're going to get hit in the head, but, you know. Have an h value of like 3 pi over 5 and a period of pi over 4. Fractions are your friends. They're parts of things. Anyway, here's where drawing your graph a little bit longer than what you need to is helpful. We know it's got to go to the right. We also know it's got to move down. So what I might do is also draw the lower leg of it longer, so I have more space. I'm over-exaggerating where it's going to be. Be okay with that? Also, when I go to draw in my parent function, I know my ending point is going to be at pi over 2. I'm not going to place that all the way out because I'm going to have to move this pi over 2 this way eventually anyway, because I'm going to have to add to it. Because if my ending spot is pi over 2, when I shift it, where's my new ending spot going to wind up being with this h? It's going to wind up at pi, okay? One of the things you have to move around. So I'm just using this as kind of like gauging a rough idea of where it's going to wind up when I'm done. We know our graph we're going to put in to start with is going to be y equals 3 sine of 4x as our parent function. I got to get my breakpoints. My breakpoints, half of a half is a fourth, so pi over 4. Half of that is pi over 8. And adding back, we get 3 pi over 8. Okay. Sine graph, a value is positive. Where does it start? 0. 0, then it goes to the a value, back to 0, opposite a value, back to 0. I get that. Now, Kobe, you talked about this yesterday about should we list out the ordered pairs. Here's where if you list out the ordered pairs, it makes your life so much easier. Okay? If we list these out, we have 0, 0. Pi over 8, 3. Pi over 4, 0. 3 pi over 8, negative 3. And then pi over 2, 0. I have all of those for my originals. To each one of those points, I have to move them in h and a k. The h values go with which ones? X's. Therefore, k's go with y. So I know I'm going to take the x, and I'm going to add pi over 2. The y value, I'm going to subtract 2. And I do that to all of these ordered pairs. That's it. That's how I list out where I'm going. Or, if you want to think of it another way, if you start back at your original endpoint, you know that's still going to have an endpoint. Right? You can get that last endpoint and then go to your first one and move that and then work your halfways. It can get messy if you do that because sometimes your shift could wind up in the middle of what your original period was for the parent function. So that's why using the ordered pairs kind of alleviates that a little bit. All right? So what's 0 plus pi over 2? What's 0 plus negative 2? So my first ordered pair would be at pi over 2, negative 2. pi over 8 and pi over 2. 1/8 plus 4/8. 5/8. So you get 5 pi over 8. Also, by doing it this way, the adding of the fractions work out pretty easy. You don't have to worry about each, like trying to count out a common denominator for each one all at once. You're doing it individually. If you have pi in the period, just leave the pi out when you're doing the calculations. Most of these calculations you should be able to do in your head. 1/4 plus 1/2. 3/4. So it's 3 pi over 4. 1 minus 2. I'm sorry, 0 minus 2, excuse me. 3/8 plus 4/8, 7/8. And be at -5 then. And then 1/2 and 1/2 is a. So what's happening is this 0 line, where it crosses the axis, those 3 spots, moved to the -2 spot, because that's where it zeroes itself out. See how that works? Those 3 spots should have the same 3 y values again. So now when you go back to graph everything, you now know your breakpoints. You have pi, 3 pi over 4, 5 pi over 8, and 7 pi over 8. It's very easy to do the order, bless you, very easy to do the ordered pairs first. Just take your time to write them out. And then just walk it. We start at -2. We go to +1. Back to -2. Gotta go to -5. Oh, I'm off a bit here, I'm sorry. It starts at pi over 2, excuse me. Just realized I started in the wrong spot. -5. And down here. And here's your final curve. That's how these work. Hopefully it's not very scary. It just takes a little bit of time to get used to the adding of the fraction again. That's about the most difficult thing that I think that you guys will have with this. Okay. Well, nobody's crying, so that's a good sign.
Is it alright to make 2 graphs?
Boo. Boo. What's that?
Is it okay to make like 2 graphs, like, so you make the first one, and then you make the second
Oh, just do a
graph
separate
shit?
one?
Yeah, so it's not so crowded.
I usually, you can, but you can run out of, you can make, it just takes up so much space. You know,
Yeah.
because when you have a parent function, because we've never really done 2 graphs with parent functions before, that way it's all in the same line with the dotted and the solid. I guess it's really not the end of the world, but I just, for the sake of space-wise, I don't think you really need it. I don't think you really need to. But I guess if you're more comfortable doing it that way, I guess I can't say no. It's not wrong. As long as you give me the order pairs now, I think it's just quicker to do it this way. Let's do another one. It's exciting. Quick, give me a number.
12.
Oh my God.
Plus or minus?
Two.
Minus
Minus
12.
4.
18.
Wait,
What the? Couldn't have been like 3.
It's not my fault. It wasn't me.
You said.
Direct your attention to the blonde-haired girl in the front row. And that's the fourth time. What do you think we're going to do first?
change the 18
Yeah, that's what I was going to say. Let's just do that as a -4.
You said just pick a
See,
number.
I said 4. I said.
I didn't hear you.
2.
I said 12.
I only wrote -8.
Wait, or did you say 2?
I said 4.
Joking. I gotta, my brother showed me a video of Deaf Jeff. The gag they pulled on Jeff Rancourt. This doesn't take long. I'll let you guys see it. It's baseball player. It's very funny.
You see the one where the people are like rinsing off after getting in the ocean, and then they kept pouring the soap on their hands. Like
No.
Like while they were taking a shower, they just kept having rinse off the soap.
No. Let's just say he got transferred to a new team, and everybody on the new team told him that one of the guys was deaf. And he thought he was deaf for like the next 3-4 weeks. They just got this gag going on.
It's funny.
It's really, really funny.
That'd be hard to pull off in 3 to 4 weeks.
They did. It was a minor league baseball team. They just pulled it off.
Like, imagine being that guy. He's like, I can't. That sucks.
And the guy was a pitcher. It's like they go up to the mound and they talk to each other with their faces covered. The guy didn't even realize he was doing it.
They did this during games.
Yeah, I'll put it on my website and I'll link it. You guys can watch the video. It's about 6 minutes of pure funniness. So again,
Right now.
first thing you're gonna do is label your amplitude. Find your period. Your amplitude is 2. Your period is going to be 2 pi over 2/3. So when you flip that, you get
3 pi.
3 pi. Okay. You get 3 pi when you're done with that. All right. Your H and your K. Your H is a positive 1/4. Your K is a negative 1/4. So, oh, look at this. We're going right and down again.
Yeah.
We don't always do this.
Nah, you probably
It's
do.
just.
Start out by labeling out your breakpoints. Yes, ma'am.
Do you ever go with that one?
Yes, ma'am.
So then your graph is that one?
Yes, ma'am. And when you do that, you just put when you put in your T part, you just move that over to the right more. You extend it back to the left. Once you get used to how they move around, you visualize. We don't visualize, but you can kind of guesstimate where the shift's going to occur. So we get what is that? 3 pi over 2.
Yep.
3 pi over 4. And let's see, 3/4 plus 6/4 is 9/4, so 9 pi over 4.
Yeah.
You guys catching on to the trick of just taking the first 2 fractions and adding together yet?
Yeah.
That's all it is. Half, add it back, you're here. It's 3/4, 3/4 of the way, so it's a nice little trick. So you've got your breakpoints. So we have, cosine starts at A was positive, and then the original, and this
Oh,
is
cosine, darn it.
the extra spicy. And on the extra spicy, what do you do to each one of those ordered pairs?
You add
Yeah,
pi over
you add the
2 pi.
pi over 4 and you
pi over 4.
subtract 4. So it's going to be x plus pi over 4 and, y minus 4. So, excuse me, here we get pi over 4, negative 2. Pi, negative 4. 6 pi over 7 pi over 4, negative 6. 10 pi over 4, which is 5 pi over 2. Negative 4. 3 pi as a fourth would be, thank you. And negative 2. So, bless you. So in this case here, my idea of moving it completely over might not have been the greatest idea because my shift is very small. So maybe I should have done something different. And you'll get used to this, and it's okay. Because you can do this on your paper. So if you space it out a little bit further on your paper like that, it works out great.
Yeah, I can't do that.
I'm just gonna draw a new graph and all that.
You can, that's fine, but if I ask you to list out the ordered pairs, make sure you simplify them. Which I've been known to do. So we'll call this a quarter, and we'll call that negative 2. Pi. Pi is after 3 pi over 4, so we'll call that pi. And that is negative 4. 7 pi over 4 is after 3 pi over 4, or over 2. We have our breakpoints, and then we have pi over 4. Over 2, excuse me. It's not a very, I shouldn't say it like this because I know Caitlin's going to roll her eyes at me. I hope that it is not a difficult task. It is kind of the same process each time. The trickiest part of this generally is the adding of the fractions. And that's usually what you guys get hung up on. Every one of these problems is the same thing. It really is. It's just a matter of adding, subtracting fractions. Once you're able to identify your, and the whole key to unlocking the problem itself is getting the correct period. If you can get the correct period, the sub's a piece of cake. Right. Am I oversimplifying that? I hope not. Oh, I want one more. Do that one. I think I did mine wrong. Oh well. Anyway, hopefully this is quick. Did you catch the trick about the 4?
Yep.
So A value is 3, B value, here you gotta take the 4 out, which gives you a shift of pi over 4. Ah, there it is.
I was gonna go for it, and I was like, maybe.
That's it. That's the trick.
I just didn't know. I was like, do I go for it? I wrote it down.
You get a pi over 2 period with a shift of pi over 4. Huh? Yeah, so you gotta move to the right. Excuse me. Left. Excuse me. So your H is negative pi over 4. And your K is 2. So you're going left, up.
I knew it was on top.
The trick here that's moving left is because you got the plus pi in there. Yes, sir?
So should B never be 1?
What's that?
Should B never be 1?
B could be 1, absolutely.
But like if there's stuff to the right of it, you should always try to take something out.
Yeah. Yep. And that's the trick. For this style, the B value has to be out before the parentheses. So whatever it is inside that, whatever number it is, you factor it out and you just divide the other part by it, and that's how it works.
Okay.
Yes, ma'am.
But if it was just x plus 5, then it could be,
Yes. Yep. And that's a trick for this one, so, do you want me to finish? I mean,
That's a
That's
more
pretty
kid.
good.
Yeah, kill it.
no, that's what you do. Let me give you some problems. Oh, I had the problems here. What I want you guys to do is that 35 goes,
What page is it?
Probably 8:36.
probably 8:45.
2 hours close.
So it's 8:45, it's 14:2. Let's do 38 to 43, that's too bad. 6 of these is enough. Maybe 9.
Like, once you do like a couple.
Yeah, that's what it is, a couple of each one, I think will be all right. We'll do these, so this, what did I say, page 845?
Uh-huh.
That's 14:2. Do those 6 with parent and the other ones. List out your order pairs. Get in the habit of listing out your order pairs. It'll help you see how the adding the fractions get going, and you'll get better at it. What we'll do then tomorrow, like I said, is we'll talk about all about the tangent graphs, and then probably on Friday, we're gonna mix the graphs together, and then we're gonna do the more of the writing of the equations given shifts. So we probably won't do the recips on Friday, we might do the reciprocal stuff on Monday. Yes, ma'am?
So if there's no each value, then you just roll up or down?
Correct.
For the week?
Yeah. Yep, that one just moves down. Right. You okay then? Coolio.
Perfectly fine.